Ocean acidification, its causes and effects on marine life.
So, what is ocean acidification? Ocean acidification refers to a reduction in the pH of the ocean over an extended period of time, caused primarily by the uptake of carbon dioxide from the atmosphere. Ocean acidification is rapidly changing the carbonate system of the world's oceans. Past mass extinction events have been linked to ocean acidification, and the current rate of change in seawater chemistry is unprecedented. Put simply, it's a harmful process in which excess carbon dioxide in the atmosphere enters the ocean and dissolves, thus making the ocean more acidic due to the carbonic acid.
With increased ocean acidification, life has become increasingly difficult for marine organisms such as plankton and mollusks and coral. Mollusks have a harder time because the lack of calcium carbonate does not allow their shells and skeletons to form, which ultimately reduces their chance of survival. Increased acidity slows the growth of calcium carbonate structures, and at some times, under severe conditions, can dissolve the structures faster than they form. Ultimately, ocean acidification is bad.
Throughout this presentation, we'll be exploring some of the causes, effects, and some solutions for ocean acidification, and hopefully, one day, the problem will be solved.
In the grand scheme of things, ocean acidification might not initially seem like the biggest issue to focus on. It didn't start to become a prevalent topic until scientists started noticing a decline in populations and the overall health of marine organisms. To name a few, corals, echinoderms, mollusks, pteropods, algae, and phytoplankton. The term itself describes a direction of change, not an endpoint to the future of the ocean itself, which means that we still have the means to change our ways. This observation raised the question of why. When the world was beginning to industrialize in the 1800s, emissions into the atmosphere increased exponentially as a result. Since then, we've significantly grown industry-wise, and the resulting rise in fossil fuel usage over time has led to immense amounts of CO2 releasing into the atmosphere. As the ocean continues to absorb more CO2 from the atmosphere, pH levels decrease, which turns the ocean's waters increasingly more and more acidic. The pH of the ocean has decreased about 0.1%, and, similarly to humans, marine organisms are very sensitive to small changes in pH. Respiration, photosynthesis, and reproduction of keystone marine species are what is being affected, and negatively so. Simply put, our continued rapid use and consumption of fossil fuels has resulted in a plethora of environmental issues involving the ocean. It is important that we understand the cause of this issue because it is not just our appetite we are looking out for, but the future of entire ecosystems that are responsible for maintaining the world as we see it today. Anthropogenic carbon dioxide emissions, which are produced through the burning of coal, oil, and natural gas, are proven to increase ocean acidification. As the ocean, soil, and forests are the largest carbon sinks on Earth, they are detrimental to keeping the CO2 levels on Earth at low levels. But, unfortunately, as history proves itself, the natural remedies set in place to maintain balance will never catch up with the rate of human intrusion. Thus, it is up to us to self-regulate. Atmospheric CO2 dissolves in water, which produces carbonic acid, and thus decreases oceanic pH levels when high quantities of CO2 are rapidly and consistently being absorbed. This issue is extremely impactful because it can lead to higher mortality rates to both indicator and specialist species. Ocean acidification is fundamentally changing the chemistry of the world's oceans and threatening our marine resources. The marine organisms that we depend on for income and a source of food are at risk because it is their food that is directly and negatively affected. Acidification doesn't just affect the levels of calcium carbonate, but the nitrogen and phosphorus cycles in the ocean as well. Unlike the topic of global warming, ocean acidification is not controversial at all, as no one is denying it exists and is an issue, as increasing acidity in the ocean may impede on marine ecosystems before climate change does. Overall, we should take care to educate ourselves on this topic because it is broadly our fault that this widespread domino effect of change is occurring in the first place. It becomes our responsibility to clean up our mess, both morally and ethically. The ocean plays a vital role in nature. as it functions as a carbon sink for 40% of the CO2 in the atmosphere. While this does have its benefits, the ocean can only hold so much CO2 before there are dire consequences. The sheer amount of pollution in the atmosphere is unprecedented, and the constant input of it into the ocean is harming native species. The more acidic seawater becomes, the less calcium carbonate it can hold, and many marine species, including coral, need calcium carbonate to build their protective shells. Without it, mollusk and coral growth regresses and becomes weaker. With the lack of calcium carbonate, coral reefs are increasingly breakable, slow-growing, and erode faster than they can grow. Another effect of ocean acidification is coral bleaching. Today, around 75% of the world's tropical coral reefs have experienced changes in acidity severe enough to trigger bleaching. Take into consideration that coral is not only fragile, but unable to survive throughout the drastic changes the Earth is undergoing. These changes ultimately lead to coral bleaching and the loss of habitat for many other organisms. The ocean's pH is decreasing, and organisms themselves, habitats, and so much more are being affected. Additionally, increased seawater acidity also reduces phytoplankton's ability to form strong cell walls, making them not only smaller, but less effective at storing carbon. Phytoplankton are vital to marine life, as they use photosynthesis to convert carbon in the atmosphere into carbon in their bodies, and function as the primary producers of oceanic food webs. Not only do they remove huge amounts of carbon, they also fuel the entire marine food web, which could in turn alter our food web. Overall, affecting such vital species for marine life is why carbonic acidification can lead to some horrible consequences.
Effects. Today, more than 1 billion people worldwide rely on food from the ocean as their primary source of protein. Approximately 20% of the world's population derives at least 1/5 of its animal protein intake from fish. In addition, many jobs and economies in the United States and around the world depend on fish and shellfish, thus decreasing harvests would harm less developed nations that have fewer agricultural alternatives. These challenges may also influence migration, encouraging individuals to move towards more urban regions, which may lead to further social disruption and even conflict. Overall, ocean acidification is having a series of negative effects on many marine species. This could alter marine food chains and food supply to humans. It could also negatively affect human health due to the increasing risk of shellfish poisoning and exposure to harmful algae blooms. Acidification could also decrease storm protection from reefs, tourism opportunities, and other benefits that are difficult to value. The complex food webs that support marine life are being threatened, as well as the global economy.